Hello, everyone. So this is the podcast for, as you can see, May 17th. And what you guys are going to be doing is working with rational equations. Rational means you can write it as a fraction. Okay, so it's equations that are written in fraction form. Like this would be a version of a rational equation. What I want to do is first work with the understanding of an expression versus an equation. These are all expressions. They don't have an equal sign with it. And there are certain things you can only do to expressions, but you can also do more things to equations. So first off, with an expression, the only thing I'm allowed to do is multiply it by something that's worth 1, otherwise I change its value. So an example, if I were to multiply it by 5 over 5, 5 over 5 is worth 1, so I get 10x over 15. That's still worth the 2/3 x. Thinking of when you were dealing with radians, if I want to get degrees, I could multiply by 180 over pi. That's worth 1. And you would multiply across to cancel stuff out and get what it's worth. Like the pi's would cancel, the 4 would go into 180, and you would just get the answer. Okay? Here, when you're adding or subtracting, the only thing you're allowed to add or subtract is 0. To get you there, what if I were to add 3 and subtract 3? Isn't that worth 0? And 17 plus 3 is 20, and 20 minus 3 is still worth 17. It doesn't look like 17 anymore, but it's 20 minus 3, which is still worth 17. I added 0 to it. Okay? So the only thing you can do to an expression is either add 0 or multiply by 1. Nothing else is legal. When you have an equation, I can subtract 5 as long as I'm doing it from both sides. So it's not adding 0 or subtracting 0. I'm actually taking a number other than 0 and adding it to both sides. Then I can multiply by something other than 1. In this case, I'm going to multiply by 3/2 to both sides. So I get x is equal to 9/2. Okay? Now, why I bring that up is when you have these rational equations, so you got these funky fractions going on and you want to solve them, typically what you've done is you've gotten rid of adding or subtracting first. But you can get rid of multiplication first. It's not usually what you've done, but you can, and let me show you. Let's say you're dividing by this 3. As long as I multiply everybody by 3, it's legal. So the 3 would cancel here, plus 15 is equal to 24. That's still okay. Usually you get rid of this 5 first, then get rid of this 2/3. But you can change the order and do it a little bit differently if you do it correctly. Why I bring that up is because this, subtracting the 5 to the other side isn't going to help. It's not going to go anywhere. What I need to get rid of is this x minus 8 in the bottom. And notice that is over 1. And here, notice I multiplied every piece, every term by the same thing. So if I want to get rid of this x minus 8, just like I wanted to get rid of this 3, I'm going to multiply everybody by x minus 8 over 1. Times x minus 8 over 1 times x minus 8 over 1. In this piece it cancels. In this piece it cancels. In this piece it does not cancel. There's like a parenthesis around it. It's 5 times all of that. This negative sign stays with the x. 5 multiplies in, so if you want, I'll just write it like this first. And this negative stays with the 8. So I have to distribute that 5 in. Now I can collect like terms. And now it's just like solving the equations originally. I'm going to add 40 to both sides. So I get 4x is equal to, what would that be, 32? Then divide by 4, and you get x is equal to 8. Okay, now, in looking at this answer, this actually isn't an answer. How do I know that? Well, if I were to go back, whoops, I didn't mean to hit that one. We got x is equal to 8. But if I were to fill it in to the original equation, I get negative 8 over 8 minus 8 plus 5 is equal to negative 8 over 8 minus 8. Look at this 8 minus 8. That's negative 8 over 0 plus 5 is equal to negative 8 over 0. You can't divide by 0. So there's actually no solution to this question. Okay? Even though algebraically we did everything fine, there's actually no solution for it. Okay? So you just have to look back at the original equation and see, are you getting this dividing by 0 thingy? Okay. This one, I'm going to multiply everybody by x minus 6 over 1. X minus, 6 over 1 times x minus 6 over 1. Now in the case like this, again, remember it's considered like a parenthesis. So I have negative 9 times x minus 6. This cancels. Plus x equals, this cancels, 6. Distribute the negative 9 in. Don't forget to carry that negative sign with it. So it becomes plus 54 plus x is equal to 6. Collect like terms. Subtract the 54 from both sides. So you get negative 8 is equal to, so would that be 48, negative 48? Hey, it looks like this one's not going to work either. Divide by negative 8, and you get x is equal to 6. Yeah, and you fill it back in, and it blows up again. It's funny if all the examples I picked don't work. So again, this one would be no solution. Because when you fill it back in, you're getting, like, for example, this. It's funny that all the examples I picked from Delta Math are the ones that are no solution. Let's see if this one's no solution. Okay, multiply everybody by x minus 4 over 1. So you get 3, x minus 4. This cancels out. Plus 2x equals, this cancels out, 8. 3x minus 12 plus 2x is equal to 8. Yeah, this one comes up with 4, so there's no solution. I think I can see the answer already. Minus 12 is equal to 8. Add the 12, we get 20. 5x is equal to 20. Divide by 5, x is equal to 4. Yeah, no solution again. That's weird. Okay, I can't imagine I picked 3 in a row that are all no solution, but that's bizarre. Anyways, thank you guys for your time. Have yourself a great one, and talk to you soon.